Hello IB. In 5B and the rest of the chapter, we look in more detail at the transformation of graphs. We've done a lot of this already, and so it should be a lot of revision. The key thing is that we can describe it algebraically as well as a full geometric description. That means that you can put into words what's happening to the parent function in each case. So let's just quickly run through what we've done already using the quadratic y equals x squared as our example. Do you remember if we wanted to shift this up and down, then we'd be adding a value like in the y direction to shift this up. So our function would be coming, say, something like y equal to x squared, let's say plus 3, in which case our function here, quick sketch here, is going to be moving up 3 units to there. All right, so we're getting a shift. Oh, need a pen. We want to shift up and down. Okay, of 3 units. So that's our geometric description. What we're doing with our function is basically going f of x plus k. So we move it up a certain amount. Oh, okay, we're going to go make that a b. We'll go b for that. If we want to shift it left or right, do you remember how we did that? So let's say we've got our curve again here. It's not really traced over properly. And if we want to now shift this to the right, across here, let's take it to 2. Do you remember how we did that? Then we do y equals, and in this case it's to do with the x, so it's shifting. And remember, it's the opposite. X is always the opposite of what we think, whereas the y is the same. So this is a shift. There's no change in the graph to the right of 3 units, 2 units. So in terms of a general way of explaining that, we're doing f of x minus a. We're changing our function. We're getting a shift in the function. So if we had a vector translation where we've got a vector change of a, b, that means we've got f of x minus a plus b. So the y change is outside the function, whereas the x change or shift is within, it's affecting the x, so it's within that part of the notation. So at the end of this section here, we do a lot of practice with that. When we're doing our reflection, remember if we want to reflect it up or down or left to right. So if we're going upside down, so we want to basically get this curve and reflect it downwards, we're going to come down like this. Do you remember how to do that? Remember, if we're reflecting, there's no change in shape, like the last one. The shape is still the same. So in our equation y equal to x squared, we now have minus x squared. So we can then see that it's reflected downwards. The y values were positive and now they become negative. Put your x in the function, square it, then make it negative. If we wanted to shift it left-right, because this function is symmetrical, we can't see a left-right reflection. Oh, I just bumped it there. And so what I've done here, let's just set this up and we'll shift this 1 space to the right to start with. So let's just shift that over here. So that's got a shift to the right because it's -1. So now if I reflect that in our the y-axis, it means we want our curve to still go through there because that's where x is 0, it's on the y-axis. But now we want it intersecting down here. So our curve is going to be looking like this. Oh, it's not meant to line up on top of there. So basically, our points are being reflected from there over to here. That's what a reflection is about. So this point has gone over to that point, reflected around the y-axis, whereas before these points were being reflected down that direction. All right, so in this case, our graph, our minus comes inside, so we get y is equal to our brackets minus x minus 1 all squared. So the x becomes negative. So in that general notation, our f of x goes to minus f of x. And in this case, our f of x function is going to f of minus x. So wherever there's an x, like composite functions, x becomes a negative. So we have negative x minus 1. We can actually pull out the minus 1 as a common factor here, minus 1 squared, because it's in a brackets where it's squared, x plus 1 all squared. Minus 1 squared is 1. So our function now has become y equal to x plus 1 squared, which is like our original x shifted 1 unit to the left, which is what we see has happened. So that's the same as doing our reflection in the y-axis. We'll be doing more of these through this chapter. The next one, if we want to make it wider or narrow, we want to stretch these. So in this case, we're getting a stretch and our graph no longer looks the same. So there's a change in shape. Doesn't look the same. Oh, shape. So if we want to stretch it from the y perspective, so that means we want to get our function and we want to like multiply it by, so all the y values get multiplied. So let's just put an a at the front. So we get, it's a times, it's the y values are all stretched. A amount in the y direction. So for example, if we had y equal to 2x squared, we're just getting our function x squared times it by 2, then everything's going to be twice as big. So this is now going to come up to here, that's going to come up to here, and our graph gets steeper. At 0, it's still 0. 2 comes up to here. Where are we? That's 15 over 30 up to there. All right. So it's steeper in this case. If it goes, if we had y equal to a half, if we had our factor of a half, then it's going to get half as high. All right, so we're getting a stretch, and we're getting what we talk about here are scale factors. So our scale factor, oh, that's an R. Here we have a scale factor equal to 2. Here our scale factor is a half. In the x, it's the opposite. So we've found that this is the one we haven't really done a lot of. So we're now doing a transformation where we get f of x over a. Well, you can write it in different ways. Let me just jump here and have a look. They're going to use in here a qx. So let me go back and do that one. They put a q. So ax. So that'd be like having, in our example, let's go a yellow one, y equal to x over 2. If I had, whoops, 2x squared, all right? So when we expand that, that looks like y equal to 4x squared. So it looks the same. So our graph here looks the same, except it's now got a scale factor of 4. But if we think of it from an x perspective, it's been squashed in. So what was normally here is now a quarter of the way in this way, a quarter of the way in that way. So this is like times a quarter. I haven't drawn it accurately. This is times a quarter. So our scale factor here, from an x perspective, is a quarter. All right, this is purely from an x perspective. We've squashed it in a quarter of the amount. So all the x values have just gone in a quarter compared to where they were. So basically what we're doing in this chapter, as you can see, is looking through each of these options. 5C looks at the translation vertically as well as horizontally. 5D looks at the stretches, vertical stretches and a horizontal stretch, and 5E was flipping it around the axes. We're going to talk about, in terms of translation, whether we're simply going to be doing a slide and this curve stays the same shape, or whether it's going to be a stretch where the curve gets steeper or flatter and we want to talk scale factor, or whether it's a reflection, a mirror image across, and we need to know what's the line of reflection, no change of shape. And our full geometric description puts all those into words. The exercises in this section are purely getting used to going from this general notation into a specific equation. So here, when we have f of 2x, if our f of x is x squared, then f of 2x is simply going to be, means substitute the x with 2x, so we get 2x squared, we end up with 4x. B is fairly straightforward. This one in C, if we want 2f of x plus 1, it means get our f of x function, which is x squared, now multiply it by 2, outside, it's not inside with the x, and we add 1. So that function becomes, this is our transformed function. In D, if we now want f of x plus 3 minus 4, then it means we've got x plus 3. Our function says square it. That's what the function says up here. So we now square it and we subtract 4. All right? So here we can see this is involving a stretch in the y because it's outside the f of x notation, and a vertical stretch. So we've got, a vertical shift. Now note the order matters, all right, with this. So we've got it, this says do the stretch first and then the shift. If you did it the other way around, you'd get a different result. Okay, strength, a stretch, then shift. This one here, we've got 2 shifts, one in the x, one in the y. Because they're different components, the x and the y, then the order doesn't matter. All right, but here, because they were both to do with the y, the order matters. So this is a shift in the x, and then that's a shift in the y. So our curve is exactly the same shape. It's just been relocated. And you'll remember that's your vertex form. So the vertex now, for this one, it has a vertex at -3. Remember to take the negative of the x1, and -4. So it's been shifted 3 units to the left, 4 units down, and we have a new vertex. Anyway, so have a look at that. We're going to do more of these in class. And the exercises to do with this are this sort of notation. So thanks for listening and looking forward to seeing you in the lesson. Bye for now.